In this video, we're going to be talking about genotypes and phenotypes. So genotypes is based on the probability, while phenotypes is based on possibility. First, let's start with phenotypes since it's the most simplest. So let's say we're going to look at the eye part over here. So let's say your mom has blue eyes, but your dad has brown eyes. In this situation, the offspring will either have blue eyes or brown eyes. That's a simple thing we can make. That's a simple possibility that we can make. However, when it comes to genotypes, we have to look at the dominant and recessive genes that are located in the DNA. For example, let's say the dad's brown eyes are most dominant. In this situation, if it's most dominant, then the offspring has a 2/3 chance of getting brown eyes, while a 1/3 chance of getting blue eyes. I'll show you with some math. So for example, the brown is dad's eyes and mom is blue eyes. So capital B represents brown eyes and the lowercase b represents blue eyes. If there's two capital B's, that means it's 100% that it'll be brown eyes. If it's a capital B but then a lowercase b, it'll also be 100% brown eyes. And the reason why is because the capital B overrules the lowercase b. As we talked in the previous video, the smaller b means it's most recessive. However, if there are two lowercase b's, that then becomes dominant. So in this situation, in genotype, they have a 2/3 chance of being brown, 1/3 chance of being blue. But if that's looking at probability. But looking at possibility, there are only two options, either brown or blue. We can look at some more math over here. So we talked about the p-plans from Mendel's video. So now let's look at the genotype and phenotype both perspectives. So we start off with the pure generation. So that means two tall trees mated and then got this tall tree, and two short trees mated and got this short tree. Note that the lowercase t would represent the small tree, but the uppercase t would represent the large tree. If these two crossbreed, then we have a 100% chance of all of them being tall. As we went over here, the uppercase and lowercase letters, if there's an uppercase and lowercase letter, then what happens is the uppercase letter outrules it, and then it converts to the gene, like the appearance of the uppercase letter. So basically, in this situation, all of them are tall. However, so that's phenotype, but genotype is they're both uppercase T and then lowercase t. Now let's say you have both two uppercase T and lowercase t, and also two uppercase T and lowercase t. So you're breathing upon the same thing. Then you have four options: uppercase T, lowercase t, uppercase T, lowercase t, uppercase t, or lowercase t, lowercase t. We can see over here. You have a 75% chance of being tall and a 25% chance of being short. Hence, we get the ratio 3:1. Now, there's also a 25% chance you get the same gene as this one over here, or a 25% chance you get the same gene as this one over here. But a 50% chance you get the same genes of your both parents. So basically, we saw that the uppercase T to uppercase T, lowercase t, and to lowercase t is to 1:2:1. So 25% chance of this one over here, 50% chance of these two, and 25% chance of this. And for the phenotype, we see that 3 of them are tall and 1 of them is short. So with this, we can conclude that genotype is not equal to phenotype.